Hi, Bobby.
Hi, Aniruddhan. So the circuit that you have for kind of a filter, I wanted to see what's the diode across the diode. What's the maximum voltage is coming
Okay.
when
So
it's reverse bias?
I understand. So is this the circuit you're talking about?
Correct.
So I think we had a capacitor here.
Yeah.
Correct?
Yeah.
So this was Vm sin omega t. Correct. So we saw that here it just goes to Vm.
Vm.
It just stops there, no? It goes something like this. I think we showed that. It just charges to the peak value and stays there.
Yes.
Correct?
Yes.
For
Because in the
ideal
first quarter cycle, it will charge.
It will charge. Correct. Correct.
This is V naught.
This is V naught.
What about VD?
Oh, the voltage across the diode. Okay.
It is on during the first quarter cycle.
Correct.
Afterwards, it's off.
Correct. Okay. So
at that time, when it's on, of course, 0.
Correct. So this is the voltage you're interested in?
Yeah.
VD.
Yeah.
Right?
Shall we try to?
Because it's reverse bias, no?
Yeah.
After that. So this is the way we want to draw it.
Yeah.
Let's redraw the circuit.
So
that we can show the voltage across the diode, no? So I'll just show it like this.
Oh, capacitor there and diode.
Capacitor there and diode here.
Okay, okay.
So this is the voltage we are interested in.
Yeah.
Okay. Well, if this is VO, no? So I've just moved it
No,
here.
let's say I don't know. We'll start from.
Okay. But this is the same circuit we
It's the
drew,
same
right?
circuit.
But I understand. Let's start from we don't know what it is.
Yeah.
Right?
Yeah.
Okay.
So that means positive cycle,
Diode is forward biased.
forward bias,
Correct.
but not throughout.
Not throughout.
Till quarter cycle.
Till quarter cycle.
So till quarter cycle, it's going to be 0.
0. Correct?
Correct, no?
Correct. Absolutely. Correct. I understand. So we don't just want to find out, we want to find out for all time.
Yeah.
That's why you want to do this. It makes a lot of sense. Okay. So now this is VD, no?
Yeah.
So in the first quarter cycle, diode is this thing. So let me show that here. This is T by 4.
Yeah.
So at T by 4, diode, I'll use a different color. 0.
Yeah. Till
Because it's forward biased.
Yeah.
And after that, it becomes reverse
and by
biased.
the time capacitor has got
VM.
VM.
Right?
That plus
Correct.
minus VM will mark there.
Plus minus VM we'll mark here. So it is plus minus like this?
Correct.
Correct. So this is VM. Okay, yeah.
So then onwards the diode is reverse bias.
Reverse biased from then onwards. And in fact, after that, it just stays reverse biased, no? Okay. Which means the voltage across the after that, can I write KVL?
Yeah.
So VD so there is no current.
Yeah.
Capacitor voltage is fixed to VM.
Yeah.
Then the voltage across the diode. So it is, let's say it is Vm sin omega t like this. I'll take some polarity. That should also be that is equal to Vm minus Vd.
Okay.
Is that correct?
Or when Vs is 0,
Okay.
we will have minus Vm across the capacitor.
We'll have
Sorry,
minus
across the diode.
Across the diode, correct.
Okay.
No, it's just Vm, no? If the voltage source was
Oh, so you have marked VD in this
VD
direction.
in this way.
Oh, okay, okay.
Because this reverse bias diode,
Correct,
I've
correct.
just marked it VD directly like this.
Correct.
Right?
So then it will be plus Vm.
Plus Vm. Correct. Correct.
Now before that, what happened? Before that is sum of those two voltages.
Sum of those two voltages. Correct.
Okay.
So then I should just add Vm sin omega t to Vm.
Yeah.
Correct. Okay. That makes sense. So then we could just go, so I added Vm like this, right? So Now I don't have space to draw the full because I drew it too big.
Yeah.
I drew VM too big. What I will do, okay, I'll do something. I'll move this down. That will give me some space.
The VD, do you want to mark minus plus that way?
We'll mark it the other way.
Yeah.
It's easier, no?
Yeah. Because I need to flip my head and think.
Sure. We'll mark VD like this.
Yeah.
But then it will go negative, no?
Yeah. Sorry.
Now I have to move my axis again.
Sorry. Yeah.
So I'll mark it like this.
Yeah.
So till T by 4, no problem, right?
Yes.
Okay. It is 0. Across VD
yeah.
is 0.
Yeah.
So I also need to move this up.
And at T by 2, it will be minus VM.
At T by 2, VM, the VS will go to 0. It has to be minus VM.
Yeah.
Correct?
That point also we know.
So correct. So it is minus VM.
Yeah.
Somewhere here I'll say
Yeah.
like this.
Correct.
Okay. Oh, I have drawn it very T by 4.
So we have taken 2 divisions for VM.
Correct.
So here also we can take 2 divisions.
We can take 2 divisions for VM.
Yeah.
So somewhere here.
Yeah.
Okay. Correct. So this will be minus VM.
Yeah.
And if I wait for another T by 4 at 3 T by 4, I'll get 1 VM from this, and it looks like it'll go to minus 2 VM.
We will mark that VS direction during the negative cycle.
Okay. So
it will become minus plus. Huh?
it will become minus plus. Correct.
Oh, then minus plus minus plus.
Minus plus minus
Oh,
plus.
I got
That's
it.
why minus 2 VM.
So it will be 2 VM at
3 T by 4.
3 T by 4.
Because 3 T by 4 is where VM sin omega t becomes minus VM. Right? So 3 T by 4 is somewhere here.
Yeah.
T by 4, T by 2, maybe I put it too much to like this. So drawing is a little bit hard, correct? This is correct?
Yeah.
Then it would come like this, like that.
Will it go to this side?
It cannot, no?
See.
Because the capacitor is always.
Yeah.
So the capacitor has a fixed voltage of VM.
Correct.
So I'm almost just like shifting
Yes.
the whole original curve
Yeah,
down. Oh,
yeah,
I see,
yeah.
I see. Okay. So what I'll do, I'll remove all of this.
Yeah.
I'll create some space here.
Yeah.
So, correct? T by 4, good. And then so I'll just mark this T by 2, 3 T by 4. Oh, at T, this is again, VS again goes to 0.
0. At that
That
time,
means it has to go to VM,
VM.
correct?
Yeah.
So I think it is a little bit hard to, it's not to scale, no?
Or shall we just draw a sine wave above, then
It was easier, huh? Okay. So you think that may be easier? We will see. We will see which is easier. So T by 2, what I will do, I'll try to bring this to scale, the x-axis. We'll mark the x-axis points first.
Yeah.
That will help us draw. T by 2.
Yeah. Then we can mark T. That
Correct.
will be enough. Yeah.
Okay, T by 2 and then T. T is here.
Yeah.
Correct? Okay. This helps 3T by 4
Correct.
helps because it goes back to VM.
Correct.
Right? So here and here it has to pass through VM.
Yeah.
Right? So, sorry.
At T by 2 and T.
T by 2 and T. It has to pass through VM.
Because at that time VS is 0.
At that time VS is 0. And at 3T by 4 it goes to minus 2 VM.
Yeah.
So I'll also do that.
Yeah.
Okay. So
Correct.
correct. And then at 5T by 4, T plus T by 4, it will hit 0 because that's where it started. So it's still, period is still the same, no?
Yes, yes, yes.
Correct. So now I hope I can.
We'll try.
We'll try. Something like this.
Yeah. Yes.
Hmm?
Yeah.
So what we have got is basically minus Vm sin omega t minus Vm. Correct?
Yes.
Okay.
Or minus Vm sin omega t, or Vm sin omega t minus Vm, no?
No, because
It has to become 2.
if we got Vm sin omega t minus Vm, correct. Correct. It is Vm sin omega t minus Vm. Correct.
Yeah.
Because Vm sin omega t minus Vm would basically bring it to peak value of minus 2 Vm, maximum value 0.
Okay.
Correct. Correct.
Or now it has an average value of minus Vm.
It has an average value of minus Vm. That's right. That's also right.
Or you have shifted that waveform, entire waveform by minus Vm.
By minus Vm. Correct.
Can I shift up also?
If I just change the direction of the diode, will it not shift up?
That's true.
Seems like it, no?
Seems like.
Yeah, because capacitor will charge to plus Vm.
Yes.
So I'll just do the same thing.
Correct.
Right?
Correct. By the way, we started saying what's the peak voltage across the diode
Correct.
during reverse bias or
Correct.
something.
Correct.
So that will be minus 2 Vm.
Minus 2 Vm. Correct. Correct. This kind- yeah, go ahead.
If you want to shift the DC value of the waveform.
Correct. This
This
seems
seems
like a
to
very
be-
useful technique, no?
Yeah.
Nice. Just one diode, one capacitor.
Correct.
You just shift the DC value.
Correct.
Very nice.
What was the other option? Otherwise, I should have kept a floating
A
battery
floating
there.
battery in between, right? So that's a lot more difficult.
Yeah.
Correct.
And change this value if Vm changes.
If Vm changes, correct.
Somebody has to be employed to do that.
Correct.
So now the capacitor gets into that peak value in
Correct.
time and then clamp. Oh,
That's right.
Yes.
That's right. So I think you're right. You're absolutely right. So so in fact, exactly what you said, no? It it clamps the voltage.
Yes.
So because of that, this circuit is called a clamper circuit. Correct.
So it's useful if you have 2 blocks or something, units or something, and there is a level shift that is
Level
required.
shift that is happening. Correct.
Okay.
Correct.
And as you said, just by flipping the diode, you can
You can get negative clamper or positive clamper, right?